All right, welcome back. Now we're starting to get into the good shit. This is chapter 9. Chapter 9 is on systems and matrices. We are only going to do 9.1, 9.4, and 9.5. 9.2 and 9.3, I forget what they're about, but I remember them being lame, and I thought, not worth your time. Oh, 9.2 and 9.3 are on matrices. We're not doing the matrices part. You'll do that if you're going down the STEM field. That's in linear algebra. You'll cover matrices. So, systems of what? Systems of linear equations. Today we'll be doing 9.1 and 9.5. And on Thursday, we will do exclusively 9.4. One of my favorite topics. Probably not going to test you on it, but if I do, it'll be an easy one. It takes a whole day to teach that topic because it can be a pain in the ass. So systems of equations is when we have more than one equation. More than one equation that has to be solved simultaneously. That's a system of equations. The linear part will make them just lines. So a system of equations, if there's two equations, they can cross, they could not cross, or they could quite literally overlap. It can effectively be the same line. This one has one solution where they cross. This has zero solutions because they don't cross. And since they overlap here, we have infinite solutions. They give names. Later on, math teachers might give a shit. This is called a consistent system. This is an inconsistent system. And this is a dependent system. The first one is sometimes called an independent system. That's all the jargon. Let's get to some solving. We have a couple methods we can use. So for both of these approaches, or for both of them, we are going to solve 4x minus 3y equals 14, along with x minus 2y equals 1. And we're going to solve it two ways. Show you both ways. One is called the substitution method. Did I hit record? Yeah, I'm recording. And the other is called the elimination, or sometimes the addition method. They both have their uses. Everybody ready for some more? So we had 4x minus 3y equals 14. And x minus 2y equals 1. Let's do the substitution method first. Here we solve one equation for one variable and plug it into the other. This is absolutely great when one of the coefficients is 1. Or -1. It's great when that happens. It's all right when a coefficient divides evenly through the rest of its equation. And this is a hell and effing no if division would cause fractions. The coefficients causes fractions. And all this information is just within one equation. The other method requires, for it to be great, the other method requires some like traits shared by both equations. What I mean by this one is, notice my x has a coefficient of 1. This one is great for substitution because step 1, or A, I'm going to solve an equation for a single variable, and that one's easy to do. X minus 2y equals 1. Add 2y to both sides, and I get x equals 2y plus 1. B, plug it into the other equation. So wherever I have a 4 or x, I am going to replace it with 2y plus 1. Now all I have in this equation are y's and numbers. So I can solve for y. So we'll distribute, we got 8y plus 4 minus 3y equals 14. So I got 5y plus 4 equals 14. So 5y equals 10. Just subtracted the 4 from both sides. Divide by the 5 and I get y equals 2. Part C. Plug value into an original equation. I'll put this in a little box because that was my guidelines for substitution method. I'm going to go with the one that looks like it has the least amount of work. X minus 2y equals 1. I'll plug in my 2 there. Got x minus 4 equals 1. So x equals 5. And these come together to give the solution. 5, 2. You should check this in both equations. It should definitely work in one because you got one of the values from it, but plug it in both. If it doesn't work in both exactly, you erred somewhere. Sometimes just going back and looking over your work and you go, oh shit, 4 plus 2 isn't 8. Imagine that. You find your error pretty quickly. Hopefully it's near the end and not near the beginning where you have to resolve everything. But sometimes you have to resolve it all, but it's really not a lot of work. Well, it's not a lot of difficult work. This is for a 2x2 system of equations. Here we had 2 equations with 2 unknowns. Often called a 2x2. Mostly because you can solve it with a matrix that has a 2x2 matrix. But now we know the equation. We're going to solve it a different way. Let's solve this. Is everyone ready before I start pulling pages? All right. So same equation set. And this will be the elimination or addition method. Maybe I should say method, not abbreviate the meth. Here we want equations to have equal but opposite coefficients for one variable. If they don't come that way, multiply one or both equations to make it happen. By values, I should say. We'll make it so. All right, so this method is great when it already exists. With equal and opposite. Like 2x with negative 2x, something like that. We don't have that here. It's good when one of the coefficients is a multiple of the other. For the same variable between the equations. We have that here with x. 4x is a multiple of x. It's 4 times it. This sucks when they have nothing in common. But can be easier than substitution. Often when this happens, you're stuck with fractions right away in the substitution method, and you got to do a lot of work with fractions. Your solution is going to have fractions. That won't change, but at least with this method, you won't get a fraction until you solve for your first value. So I'm going to do this one as the good method, which is what we have. And then I'm going to do this one as the sucky method, so you see how it works. Because we should get, as we know, 5.2 is our answer. You should get 5.2. So the idea here is, what can I multiply this by so that I have negative 4x here? What can I multiply this equation by right here? -4, right? So -4. So I'm going to do that. -4 times x is -4x. -4 times -2y is +8y. And -4 times 1 is -4. Hit them all. You have to do it on every single thing. Now we see why it becomes the addition method or elimination method, because we are going to add them together. Add them. 4x and -4x is 0x. -3y plus 8y is 5y. And 14 and -4 is 10. You can either say add them or subtract one of them, but you need to make sure the signs are all done correctly. Clearly, we divide by 5 and we get y equals 2. And we can go and plug it in back into the equation with x minus 2y equals 1. And we get x equals 5. So if you look at it, it's almost less work. I mean, there's a lot of work going on here. You got to make sure you multiply everything correctly. But other than that, once you add it up, one of the things is just gone. Here, it wasn't gone. We had to distribute, we had to solve. There was a lot of steps after we substituted. Now let's do this on the next page. We're going to do it with y. So I will rewrite those equations there and we will do it there. There is nothing easy to multiply either equation by. Cancel y's. So in reality, you wouldn't do it. But I'll do an equation in a little bit where you kind of have to do it. And I think it's easier to show you the method when we already know what the solution is. So the idea is grab each coefficient and multiply the other equation by. But change the sign on one. Well, hold on. Yeah. We want to end up where when we add them together, they go to 0. And if I just do it right now, we're going to get 6y on both. So I'll change this one. Change the 2 to a positive. So if I multiply that by +2, I get 8x minus 6y equals 28. And then if I multiply this by -3, I get -3x plus 6y equals -3. So we add them together. And my y's go away, of course. I have 5x equals 25. X equals 5. And plug that back into an equation. You can pick either one, but I think the one that has the least amount of work is the one you should use. I like doing that in the x minus 2y equals 1. All the coefficients are small. There's not a lot of work going on here. So 5 minus 2y equals 1. -2y equals -4. And y equals 2. Guess and check is a terrible, terrible approach. This can also be done by graphing it, and you'll see these lines cross at 5 too. But being comfortable with how this operation works will help you in calculus and beyond. Guys ready for a hard one? Well, hard is relative. 2x plus 3y equals -1. 3x minus 2y equals 18. I can tell right away with my coefficients, if I just look at one equation at a time, the top one, it doesn't matter which variable I solve for, I'm going to have fractions in there. Because the coefficients don't divide evenly. Same thing with this one. So if I do the substitution method, I'm going to be working with fractions straight out the gate. That sucks, because fractions make it more likely that you're going to make a mistake. So, substitution method will yield fractions. Immediately. I don't know if the answer has a fraction in it. If it does, that's unavoidable. But the longer I wait to have to work with it, the better. So instead, I'm going to aim for the addition method. I can get rid of x's or get rid of y's. Which one should I try to get rid of? One of them is a better choice than the other. What? Why? Yes. Why is it a better choice? Because one of them's negative already, yes. Why is a better choice? Because they have opposite signs already. So all I gotta do is multiply each equation by the other one's coefficient and ignore the sign. So this 3 tells me to multiply this one by 3. And this 2 tells me to multiply this one by 2. I mean, it's not hard to multiply through by a negative number, but inevitably, you forget to do the multiple or the negative on one of them. And then you get the wrong answer, and you're like, I don't know where I got it wrong. You're like, fuck, do I really want to go through this whole problem again? If you're on a test, you do. If you're not on a test, you're kind of like, eh. All right, so if I do that one here, I've got 2 times 2x is 4x, 2 times 3y is 6y, and 2 times -1 is -2. And if I do the 3 times 3x is 9x, 3 times -2y is -6y, 3 times 18 is 54. All right, so we add them up and we get 13x equals 52. Divide by 13, we get x equals 4. Now, we got to stick it into one of the original equations. We can do either one. I happen to like the top one for a few reasons. The primary reason is the y that remains has a positive coefficient. I hate dividing by a negative. It's too easy to forget the sign. So 2 times 4 plus 3y equals -1. So we get 8 plus 3y equals -1. Subtract 8. We get 3y equals -9. Divide by 3 and I get y equals -3. The answer is a ordered pair. It's a coordinate. They go together. That's the answer. All right. Ready for more? Let's take a look at 7x plus 3y equals -5. And -14x minus 6y equals -10. Which letter you guys want to get rid of? Let's get rid of X. If I get rid of X, let's look at the coefficients of X. I got 7 and -4, 14, I mean. Looks like if I double the 7X, I'll get 14X, which means I gotta multiply that by 2. When I add them up, I get 0 equals -20. Is that true? Ever? There's no variables left. So this is false, which means there's no solution. This actually tells us something about these two lines.
I mean, they're parallel.
They're parallel. Let's take a look at -9x plus 3y equals -24. And let's put that with 3x minus y equals 8. Now here you have a coefficient that is a 1 or a -1. So you can do the substitution method. I still think it's the longer, more work intensive way to go. But I'll let you guys pick. How do you guys want to solve this? Shall I do a substitution method, or shall I get rid of X, or shall I get rid of Y? Let's get rid of Y. All right, let's get rid of Y. So I have 3y here. I don't want to multiply by a fraction to get positive Y, but I can multiply this one. If I make this -3y, I can do that by multiplying this by -3. I get -24 and -9x. Or positive 9x, sorry. What did I do here? I'm just multiplying by +3. What am I doing? Fucking it up. There we go. And I'll bring down the other line real quick, put it underneath it. That one's just bringing it down unchanged. We add them together and we get 0 on both sides. Here, I didn't change the top one. I just copied it down. Normally in the other ones, I was changing the top one, so, but here I wasn't, so. What I'm trying to do here is combine this one and this one. But with having that in the way, I think it's easier just to rewrite it down here so they're not in the way. So maybe I'll put a little squiggle. So 0 equals 0 is true all the time. Both of these is y equals 3x minus 8. Which I got from solving the bottom one real quick. They are the same line. When you simplify it. You guys ready to kick it up a notch? Hell yeah, let's do it. 2 by 2, 2 by 2. That's not how the real world works. Real world, we use X, Y, and Z. It's three-dimensional. So solving systems of 3 equations. Three x plus 4y minus 2z equals 14. 2x plus y plus 2z equals 2. Sorry, negative 9. And x minus y plus z equals negative 9 also. We do the same strategy. Eliminate one variable at a time. I do not recommend the substitution method for this problem ever. Never ever is this an easy substitution method thing. So I think it's helpful if you label them A, B, and C. Equations A, B, and C, so that when you start combining them, you can like show what you're combining. And it'll help you track what you did. You guys want to get rid of X, Y, or Z? Why?
First time having it.
That works. First time having a Z value, fuck that Z value. Let's get rid of Z. I like Z for a couple reasons. I could see right away if I add these two together, that motherfucker's gone right away. And which means if I maybe double this one, I can add it there. What we need to go is from, we start with the 3 by 3. We got 3 equations and 3 unknowns. We got to drop it down to 2 equations and 2 unknowns when we lose a variable or eliminate a variable. And finally, when we eliminate another variable, we get down to 1 equation and 1 unknown. So we're going to need to make 2 equations. Z is a good choice. I like Y also because we've got both a positive Y and a negative Y. But Z is great. Let's go with Z. So if I want to eliminate Z, I think the first way that jumped out at me was adding A and B. So I'm going to write that. I'm going to say I'm doing A plus B. Since I can do them as is, I don't like all I'm doing is adding them up. I don't think I need to rewrite them. 3x plus 2x is 5x. 4y plus y is 5y. And 14 minus 9 is 5. We now need another equation that's only got x's and y's, which means we need to combine two of them again and get rid of z, but we can't do a and b. We've already done a and b. We can either do b and c, or we can do a and c. I like a and c because z here, all I got to do is double it. So if I do a plus 2z or 2c, this will become 2z and it'll go away. But since that's going to happen, I'm going to rewrite it real quick, each of them, with that information going on. That's my a, and then my 2c is 2x negative 2y plus 2z is negative 18. That's a and 2c. If I add these up, I get 5x plus 2y equals negative 4. All right, so these are the two I'm working with now. I want to do it again and eliminate one more letter. What are you guys going to eliminate here? Why? They're already the same. All we gotta do is make one of them negative, right? I can, let's call this D, and let's call this E. I'm a big fan of labeling them. Because now I can just subtract. I can do D minus E. If it helps, rewrite them next to each other with the right signs. This is D. And if I do minus E, I have minus 5x minus 2y equals 8. 4. What the? Yeah, 4. Where the fuck did I get 8? What am I doing?
Always told 18.
Maybe. Something. I'm like, something's off. If I add these up, I get 3y equals 9, which means y equals 3. Awesome. This is a great point right here. Because now we got one of them. Now we solve backwards. Don't go back to the top, go back to one of these two right here and plug in y equals 3 into one of them. I'll plug it into the bottom one. 5x plus 2 times 3 equals negative 4. You should get the same value for x no matter which one you do. This is 5x plus 6 equals negative 4. Five x equals negative 10. And x equals negative 2. That's another thing we need. Now we've got x, we've got y. Go back and plug x and y into an original. I like C because Z doesn't even have a coefficient there. So in C, I've got x, which is negative 2, minus y, which is positive 3, plus z equals negative 9. So I have z minus 5 equals negative 9. and z equals -4. We put these all together. And we get -2, 3, -4. X, Y, Z is the way we put them together. This is called an ordered triple. Desmos doesn't graph 3D, so I can't show it to you. But this is where 3 lines in space intersect. Actually, where, yeah, 3 lines or 3 planes intersect. You'll see that when you get to calculus 3. We do a lot of 3-dimensional stuff in calculus 3. Where could you use that before then? I will show you next. Poor Wanda, she came in right on the fucking 3 equations. You came in at a really hard time to jump in.
I took a picture.
Yeah, we started with much easier.
I like to jump into.
Good. All right, so where could we do something like this without going into calc 3? Let's say we have 3 points. I have point, what do I want to use here? -5, 7. I have the point -1, -2. And I have the point 3, 5. And I want an equation, find the parabola's equation. You'll find this is a parabola when we do it. In the form y equals ax squared plus bx plus c. I think this is actually a little bit easier to look at and work with if we put the y on the right. For what we're about to do. Everyone with me so far? All right, what we're going to do is I'm going to take each of the points, plug them in, and I will have an equation in terms, plug in xy, and get an equation for a, b, and c. So if I plug in the -5 and the 7, I have a times -5 squared plus b times -5 plus c equals 7. I'm going to do that for each of them, and then I'll clean them up. A with -1 squared plus b times -1 plus c equals -2. And a times 3 squared plus b times 3 plus c equals 5. Clean that up. I've got 25A minus 5B plus C equals 7. A minus B plus C equals -2. And 9A plus 3B plus C equals 5. That's just rewriting these, dealing with the squares and putting the numbers in front. All right, you guys ready? We gotta get rid of a letter. The middle equation's got a single coefficient for 1 for all of them. Any options here? Kind of like that C, because all I gotta do is do some subtraction. So maybe let's call this big A, big B, and big C. So if I do A minus B, I have 25A minus A is 24A. -5B minus a -B is really a plus B. So -5B plus a B is -4B. And 7 minus -2 is 9.
You just subtracted.
Yeah, I just subtracted this one from this one. I'm gonna do the same thing. I'm gonna do C minus B. So if it helps, do this. We're gonna have 9 minus 1A plus 3 minus -1B. And we already know the C's go away. And 5 minus -2. This is 8A plus 4B equals 7. And I'm going to call that D and E. It looks like if I just add D and E together, the B's go away. So I have 24A plus 8A is 32A. Equals 9 plus 7 is 16. This sucks. We're going to have a fraction. There's no avoiding it. A equals 1/2 if we reduce it. I'm going to put a box around it so I don't lose it. I'm going to go back up into D or E and plug it in and solve for B. I think E has got smaller numbers overall, so I'm going to plug it into E. I've got 8 times 1/2 plus 4b equals 7. So 4 plus 4b equals 7. Or b equals 3. And b equals 3/4. Finally, we got to go back to one of the other equations and plug in a and b. I like b here. I'm going to plug into a minus b plus c equals -2. 1/2 minus 3/4 plus c is -2. However you want to do it here, you can do it. You can get a common denominator and do it, or you can multiply through by the lowest common denominator. Which might be the easiest. I'll just multiply everything by 4, which is the LCD, lowest common denominator. I get 2 minus 3 plus 4c equals -8. And I've gotten rid of all the fractions for now, which makes solving for c easier. We've got 4c minus 1 equals -8. Add 1 to both sides, we get 4c equals -7. And c equals -7/4. The values are 1/2, 3/4, -7/4. Which means the parabola would be 1/2 x squared plus 3/4 x minus 7/4. Yeah,
That's just that ax squared plus bx plus c.
yeah, that's the parabola that has all those points. I'm going to show you guys. When you guys are ready, everyone got it written down? I put this equation into Desmos. .5 x squared, 0.5 is 1/2, 0.75 is 3/4, and -1.75 is -7/4. This is the line we were talking about. And all 3 points are labeled. I'll show it, but I don't know why they put it right on that motherfucker. That's a poor labeling. But they're all on there and we can see they're on there, so it worked. So it's got uses. You can see there's a bunch of shit on Desmos right now for shit coming up. You guys ready to take a look at 9.5? This is a lot of work section. I forget how many problems is in the homework. Hopefully not that many. Because they're long. Takes a while, right? I think you'll find it helpful if you label the equations while you're doing them, especially with the 3 equations. That way, if you get something wrong at the end, you can go back and go, okay, I liked a minus b for a reason. Did I actually get a minus b when I did the math? I like C minus B for a reason. Did I actually get C minus B when I did it? Because of course, you can take, for any of these systems of 3 equations and 3 unknowns, you can take the answer and plug it into each equation and it should satisfy all 3 equations. This one would suck to do with the fractions in there, but we could do it. It is doable. On the previous one we did where we had -2, 3, and -4. Plugging them in is a little bit less time consuming right there, or less work to see that they all work. You should get 14 when you do that. You should get -9 on the other 2. Let's take a look at 9.5. 9.5 is the glory. 9.5 is when we say linear equations are for chumps. 9.5 is when we look at nonlinear equations. Systems. Which means we're going to have exponents in there usually. So let's just go for some examples. X squared plus y equals 6, and x minus y equals -4. If you end up in a situation like this where one of the equations has a squared thing, or one of the variables is squared and the other one isn't. If one variable has squares and the other doesn't. Get rid of the unsquared one. It'll help you avoid having bad answers. So we could do the substitution method. If I solve this for y, I would get y equals x plus 4. And then I could go back up here and plug it in for y. I'm not going to do that because the addition method works just as well. And I think here it's faster. Or add. If I add these, the y's go away. I can't add x squared and x though. So I just have to put them side by side. They don't combine. And 6 minus 4 is 2. And you would get the same thing if you did this. If you did that, you'd get this. Solve for y, plug y in, and did it, you're going to get the same thing. All right, so we can get them all on one side. X squared plus x minus 2 equals 0. And we can factor. And we get x equals -2 or x equals 1. Still need the y value. So either go back into the one of the original equations, or I so conveniently rewrote one of them right here. When x equals -2, y equals -2 plus 4, which is 2. I get the coordinate -2, 2. When I plug in x equals 1, I get y equals 1 plus 4, which is 5. I get the coordinate 1, 5. When you have nonlinear equations, you should check all your answers. Check every answer. In both. If I do the negative 2, 2, I've got, in the top one, I've got negative 2 squared plus 2. Does that equal 6? Four plus 2 does equal 6, yes. And then I'll check it in the bottom one. Negative 2 minus y, which is positive 2. Does that equal negative 4? Yes, I get negative 4 equals negative 4. So negative 2, 2 is a valid solution. If you check the same thing on 1, 5, you should see that it works. 1 squared plus 5, does that equal 6? Yeah, 6 equals 6. And does 1 minus 5 equal negative 4? Yes, it does. So both answers work. If you went with the variable that had a square in it, the x, that try to get rid of x's there. So like maybe did a substitution for y or something, or substituted x in there. You end up getting a solution that doesn't work. I'd rather not walk you through it, but if you stick with the variable that in this situation, y had no squares, get rid of that one. You're better off. And I will show you that one. Let's turn off those wheels. This was the top one and that's the bottom one, and those are those 2 points. Negative 2, 2. And 1, 5. Ready for more? X squared plus y squared equals 9. And 9x squared plus 4y squared equals 36. One of these is a circle, one of these is an ellipse. Chapter 10 is on learning how to graph all these stuff. So we'll be doing circles and ellipses and hyperbolas in chapter 10. The process works the same here. I think doing the addition method is probably the best. If I multiply this, like y's got the lowest coefficients. So if I multiply this by negative 4 times negative 4, I get negative 4x squared minus 4y squared equals negative 36. When I add these together, I get 5x squared equals 0. Now, hopefully you can recognize that just has to be 0. But otherwise, divide both sides by 5. X squared equals 0. Take the square root of both sides. X equals, well, when you take the square root of a number, it's really plus or minus 0, but 0 doesn't have signs. So it's just X equals 0. Go back in and plug it into the other equation. So we've got y squared equals 9. And when we take the square root, we get y equals plus or minus 3. So when x equals 0, y equals 3. And when x equals 0, y equals -3. We got 2 points. That's our answer. Check them in both. I want to make sure that we finish. And I know they work. So I'm not going to do it here. But you just take those values and plug them into the equations. You guys know how to check that kind of shit. I will show you on Desmos that it does work. But you won't have that on a test, so it's not really something you want to rely on. So there's the circle. I add the ellipse. And I see I got a point at 0, 3 and 0, -3 where they intersect. You'll see that Desmos makes a handy tool for checking your work while you're done working at home. You won't have it on the test though, so don't get too reliant on it. You can always check them by plugging them in. So let's do a shitty one. One that says is going to make you walk out of here going, fuck that guy. I fucking hate Jones. Let's do one of those. X squared plus xy plus y squared equals 21. And we'll do x squared minus xy plus y squared equals 9.
Is that first one supposed to be x squared plus y squared plus y squared?
Nope, that's supposed to be plus xy. Thank you. Well, right now, if I call this A and B, it looks like I could add them together pretty easy. A plus B. Maybe I'll rewrite them on top of each other. So when I add them, I get 2x squared plus 2y squared equals 30. Or x squared plus y squared equals 15. Since they're all even numbers. I'll call that equation C. I need something else. So maybe I added them. If I subtract them, the x squareds and y squareds go away. Let's try that. Let's try a minus b. So I'll rewrite them with the correct signs. Here I get 2xy equals 12. And if I divide by 2x, I get y equals 6 over x. We'll call that D. I have a relationship. I don't have to like it. It looks like it's gonna be a shitty relationship. But hopefully it works. Let's see what happens. Let's take this, let's take D and plug it into E. If I do, I've got x squared plus 6 over x squared equals 15. So x squared plus 36 over x squared equals 15. If I clear the fractions by multiplying through by x squared, I get x to the 4th plus 36 equals 15x squared. Get them all on one side. X to the 4th minus 15x squared plus 36 equals 0. If it helps here, do u equals x squared. So we get u squared minus 15u plus 36 equals 0. Which factors to u minus 12 and u minus 3. So u equals 3 or u equals 12. Which means x squared equals 3 or x squared equals 12. So I get x, when I take the square root, I get x equals plus or minus the square root of 3 or plus or minus the square root of 12. This is the same thing as 2 root 3, but I think I'm going to leave it as 12 for now because it just might be easier to work with. So depending on how you go, this can be a pain in the ass or it can be easy. We have to plug these x's into one of these equations and find the y's. If I do this one, I'm going to take the square root. And I think I'm going to get a lot of answers. But it might be the way to go because I don't know if any of them are going to work, which ones work or not. So doing the plus or minus 3 in C. When I square it, I just get back to 3, right? It doesn't matter if it's positive or negative square root of 3. When I square it, I just get 3. I get 3 plus y squared equals 15. Y squared equals 12. So y equals plus or minus square root of 12. This actually comes up with 4 different points. I got where they're both positive. I got where they're both negative. I got where the first one's positive. And the second one's negative. And I got where the second one's positive, or the first one's negative, the second one's positive. That was just doing the plus or minus 3. I'm putting a box around it so I don't lose it. Gonna do the same thing for plus or minus 12. When I square it, doesn't matter if I do the plus or the minus. I get 12 plus y squared equals 5 or 15. So y squared equals 3. And y equals plus or minus square root of 3. So I get that same setup, but the other way around. Both of them are positive. Both of them are negative. First one's positive, second one's negative. And first one's negative, second one's positive. I'm pretty sure this has got some bad error or bad stuff in here. Because we had an x to the 4th in here. We multiplied through by an x squared to kind of change some shit up. So you gotta go through and literally plug them into the original equations. Four of them work. I already wrote down which 4. Both positive, both positive and both negative worked on both of them. The ones where we had a sign switch don't work. So there's only 4 answers. I don't have that one decimal up. I don't even know if I can. Can I decimals up a nonlinear equation like this? Holy shit, I can. Desmos has improved. The internet. Oh, I got the wrong value. That's a 9. There we go. So that looks like the negative square root of 12 and negative square root of 3. And then we got the negative square root of 3, negative square root of 12. And we get the positive ones. It's kind of neat. It's a neat picture. I better save that. Yeah.
Can you say which ones are which again? I was totally blanking. Which ones are the negative ones?
If I look at the quadrant, there was negative right here. This one's got this says -3 and -1, -3.4. That's got to be the square root of 12. And then the 1.732 I know is the square root of 3. So this is negative root 12, negative root 3. And then I got the opposite order, negative root 3, negative root 12. And up here we have the positive versions of those two. That's kind of neat. Told you weren't going to like it though. Because without graphing them on Desmos, you don't know which one of these works, which one of these don't. But there is something we can kind of look at and get like an idea. X squared and Y squared on both of these are always positive. I don't know if that helps. Yeah, it does. Especially on this one. Because both of them, I've got 12 and a 3, square root of 12, square root of 3. If I square both of them, 12 and square root of 12, square root of 3, these add up to 15 on this one. So that's the easiest one to check in. In B, you have negative xy plus 15 equals 9, regardless of which combination you plug in. So we need to make sure the only way 15 goes down to 9 is if this ends up being a negative number, which means x and y have to have the same sign. Because right now the number is negative. If I make x negative and y positive, this becomes 15 plus xy. That's just a number larger than 15. It's a lot of calculator work is probably the easiest way to go. I have a couple more, but I don't know that you want to see a couple more. Do you guys want to see a couple more, like one more? Or are you guys good? There's a lot going on here, and I don't want to. I think this one's actually worth starting. Let's start this one. X squared plus y squared equals 4. Negative absolute value of x plus y equals 0. The easiest way to work with the absolute values is to square them. When we have y equals, if I solve this, this is y equals the absolute value of x. This means y equals x for x greater than or equal to 0, and y equals negative for x less than 0. But if I square it, I just get y squared equals x squared on all of that. Y squared equals x squared. If you do this though, we squared this. There's gonna be answers that are probably wrong. Bad juju answers is what I like to call them. In fact, if you work through this later, you should get x equals plus or minus root 2, y equals plus or minus root 2, which means you have 4 combinations. They're both positive. They're both negative. First one's positive, second one's negative. Second one's positive, or first one's positive, second one's. First one's negative, second one's positive. Which one of these actually work? Here it's the. I've got listed that root 2 works. And negative root 2 positive, that one works. Oh, I know why. These are the ones where y is greater than 0 on both. We know that's a requirement here. Another one that you can try later on, I'll give you the answers for it. X squared plus y squared equals 6. 3x squared plus 2y squared equals 8. You get x equals plus or minus 2i, and y equals plus or minus square root of 10. So these are complex answers. Desmos definitely won't graph these. So you got 2i root 10, negative 2i, negative root 10. And we change them up. Positive 2i, negative root 10, and negative 2i, positive root 10. I think on that one, they all work. When we square them, the negative signs go away. That's it for today's lecture. Wasn't that fun? On Thursday, you will learn the greatest technique ever. Partial fraction decomposition. Yeah, it's a mouthful, isn't it? It's a fucking mouthful. And guess what? It's a lot of work too. But it's super cool. You too.
Good day, thank you.
You too.
Thank you.
See you guys on Thursday.
Yeah.